Hi guys, so today we are going to do lesson 4-10. So we are going to relate tables, graphs, and equations. Okay, so your ICANN is going to analyze the relationship between the dependent and independent variables in the tables, graph, and equations. So the solve and discuss, so you can kind of look at this, read over it in your packet, maybe pause the video first and kind of read over and see if you can think of some ideas to jot down before I walk you through this. So Nancy walks 4 blocks to Maria's house. Together they continue the walk. The walk can be described as n equals m plus 4, where n is the number of blocks Nancy walks and m is the number of blocks Maria walks. Describe how the equation, data table, and graph reflect the walk. Okay, so again, here is our equation. N equals m plus 4. So here's my table. So if m is 1, n is 5. So Nancy is the one that is walking more of the distance. She's walking to Maria's house. So in the end, it's saying here that Maria walked 1, maybe mile, and Nancy walked 5. Continue on. We have 2 for Maria, 6 total for Nancy, and we have 3 for Maria, 7 total for Nancy, which makes sense. Nancy started off with already 4 miles or blocks, that is what it is, blocks before she met up with Maria. So that would make sense in her equation here that she would already have 4 blocks on Maria. The graph over here says that the same thing that the table does. Over here we have the number of blocks Maria walked, m. So when she walks 1, then Nancy is walking 5, and we have kind of going up that way. So this would make this the independent variable, while this side would be the dependent variable. Maria's independent and Nancy's dependent. It depends on how many blocks Maria walks or how many total blocks Nancy is going to walk. So it says, how can you use the values in row 1 of the data table to describe the relationship shown? I kind of already did that with our independent and dependent variables, talking through there. It says, draw a line through the points on the graph. What is the ordered pair when m is 5? So our lines here, this is a straight line, so which means it's linear. So when I have a linear line, I can continue my line as straight as we can. And at m equals 5, what point that would intersect our graph here. So when m equals 5, my ordered pair would be 5, 9. Because on my line, it intersects at this point here, and then that would be 9 on my graph there as well. I could also, if I substituted this into my equation here, if I have n equals m plus 4, if I have 5 plus 4, I should get 9. All right, so let's get to the examples. All right, so here we have a Booster Club members want to raise $50 to donate to the local charity. They buy pom-poms for 55 cents each. How many pom-poms do they need to sell to reach the fundraising goal? So I've kind of laid this out into steps that you guys can take to get your answer. Now, do we always have to follow these exact steps? No, but they all relate to one another. A table, a graph, and an equation all have the same consistent relationship between the 3 of them. They all are saying the exact same thing, just in different forms. Now, the first thing that we have to look at is over here. The Booster Club is fundraising $1 for each pom-pom, but they have to make a price of 55 cents each for the pom-poms. So they're not actually making $1 every time they sell a pom-pom. They're going to actually be making 45 cents for each pom-pom. So if I wanted to fill in my table here, I had to think, okay, so if I sell 10 pom-poms, how much money am I actually raising? So I don't want to do 10 and times it by my $1 here. I want to do my 10 and multiply it by my 0.45, because that is going to tell me what my total that I'm actually making off the pom-poms, not just my profit. Okay, so I have here my 0.45 times my 10, and I'm going to raise a total of $4.50. Okay, let's try it again for another value. So 50, so I have 0.45 times 50, and my total is going to be $22.50. So notice selling 50 pom-poms doesn't get me my $50 I want to donate to a charity. So then we try again. So let's do 110. So I have 0.45 times 110. And I'm going to get $49.50. So almost there with 110. Okay. So I have my table, which from my table I can create ordered pairs, because my independent variable is going to be the x value here, so which is in tables is always the left or the top, and then my dependent one, which is my y, is going to be the right side or the bottom in my tables. So the ordered pairs I'm looking at are 10, 4.5, 50, 22.5, and 110, which is 49.5. All right, so plotting my points. So if I already have my numbers kind of posted in here. So I have, if this is 25, because that's 50, so 10 is probably closer over here, and I want to go 450, which is not very high, to get my point there. 50, and then I have like 22, 50, again, not very high, but close to that 25 mark. And then I have 110, so I'm just going to go a little bit above the 100, and then right below my 50. All right. My line's pretty straight there. So writing my equation to describe the relationship, I kind of can go back to my table here when I was substituting in a value to figure out how much money was raised. Each time I was multiplying by 45 cents. So I can make my equation here where I'm going to multiply 0.45 times x, and each time that's going to give me my y. Since it's an equation, I need an equal sign. So you're going to have multiple variables here to create your actual equation in the end. So here we go. So now it's time for you guys to try one on your own. Again, please pause the video to work through your problem. So pause now, and you can check it in just a second. All right, guys, so you should have paused it before you are seeing my answers here. So completing the table, they are using, they are only making 0.41 cents each one. So here's my, completing my table, my graph. Here's the equation that we would be using. And then solving for $50 to raise is approximately 122 pom-poms. Okay. So now going to example 2, it says here that the temperature was 6 degrees at 8 a.m. and it increased by 2 degrees each hour for 6 hours one spring day. What is the temperature after 6 hours? So again, we want to start here. So saying that 0 hours is at that 8 a.m. time. So at 8 a.m., the temperature is going to be 6 degrees. Okay, so then after 2 hours, so each hour it's increasing 2 degrees. So if it's increasing 2 degrees in 1 hour and 2 hours, it's going to increase by 4 degrees. Okay, so here I'm going to have my 6, but it's increasing by 4 there. So I'm going to have 10 degrees. Okay, and then I have my another 2-hour jump here. So I'm going to have another increase here of another 4 degrees. So 14. And then lastly, I'm going to have another 2-hour jump. So I'm going to have another 4 degrees that increase here. So now I'm at 18. All right. So here are my ordered pairs. I'm going to start at 0, 6. I'm going to have 2, 10, 4, 14, and 6, 18. All right. So plotting these points on my grid here. And 6, 18. There we go. All right. Now it wants us to describe the relationship using an equation. So first of all, guys, my temperature. So if I want to say that's my that's going to be my dependent variable. So I could use T as my variable and H as my hours. So it depends on how many hours I have. I'm increasing by 2 for each hour. So I'm going to say 2H. So 2 times however many hours I have. And then, but I started at 6 degrees. So I have to have plus 6. And that is going to be what my temperature is going to equal. So then there's my equation. So the only difference between this one is that we had kind of like a starting point. We had to start above basically 0 before we increased by anything there. All right, here's another try it for you guys. So again, pause the video, try it, and then check your work with me in just a moment. All right, here's this try it, guys. Again, here in this one was saying that it costs $5 for their supplies, and then they're selling at 2 apiece. So they actually, because they have to spend money to make money, they have a -5 here to start with. They're already in the hole like a -5, and then they started selling things for $2 each. So here's your equation, which relates here to your graph or your table, and then here's your graph. Now they wanted to know when the company is going to make a $15 profit, so I did it 2 ways. Here I kind of extended my line here. So right here up at the top here, that would be at 10 for your $15 profit over here, or I kind of solved my equation to also get that 10 is my answer here. All right, so last thing, guys, you have to do is your do you understands. Again, pause the video while and try to answer these questions, and then you can play the video to compare your work. All right, so do you understand? How can you analyze the relationship between dependent and independent variables using tables, graphs, and equations? So first, we would want to make a table here with at least 3 values. Use those values here to make ordered pairs and graph the ordered pairs. And then 3, we want to write an equation to represent the relationship. And then the second question here just asked you to complete the table. Your value down here could be different than mine, but our line should be the same, whether you chose to go with 4 or if you chose to stick with just 3. But our line should still be lined up. So kind of rate your understanding, guys. If you have questions, you can ask me and go over any homework problems that you guys have.